Hello students, this is Neha Mathur and today we are going to discuss node and mesh analysis. But before starting the topic, consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. Fine. So our today's topic is node and mesh analysis. Basically these two are most important theorems that is related to solve any electrical circuit. So whenever you want to solve any electrical circuit, you may have two most easiest options and these are node and mesh analysis. So we are going to discuss these two methods one by one. So the first one is node analysis and the second method is mesh analysis. Basically in both the methods we have some number of steps and just by following all those steps you can solve the questions related to any of the two methods. So we will discuss one by one all the steps related to both the methods. But firstly I am going to discuss node analysis. See, as the name indicating node analysis, that means you will have to first identify all the nodes which you are analyzing in your given circuit. Similarly in mesh analysis, firstly you will have to identify all the meshes which is given in your any electrical circuit. So the first thing is what is node and what is mesh. I already discussed both the terms in KVL and KCL methods related to electrical network in my last video. So please follow that so that you will be able to understand the proper meaning of node and mesh. So now come with the node analysis. There are basically the complete method to understand the node analysis is itself divided into 4 or 5 steps. So we will discuss one by one all the steps and after the complete reviewing of all these steps it will be easy to understand the actual concept of nodal analysis. So the first step is the first task that is actually useful related to node analysis is identify all the principal nodes. Firstly you will have to identify all the relevant node just by observing the specific circuit. So once you have done with the complete identification of all the principal nodes, then you will have to mention one specific principal node as a reference node. Suppose you have any given circuit and in that circuit you have 3 to 4 principal nodes. Now among these 3 to 4 principal nodes you will have to mention one principal node as a reference node and that reference node is nothing but simply a connection that is indicating ground. That means out of all the possible principal node, the one node is treated as reference node and reference node means a proper ground connection. So the first step is just obtaining all the principal nodes and I am again repeating, node means a junction or a point where two or more branches are joined. Fine. So first step is just the identification of the principal node. Now what about the second step? I am mentioning in a small indication what is the actual meaning of the first step. So the first step is identify principal node and mention one as a reference node and reference node is nothing but a ground connection. This is about the first step related to node analysis. Now come with the second step. Now the second step is, this is the easiest step, just labeling all the principal nodes. So in the second step you will have to mention the label to that particular principal nodes. Just an example, suppose you have 3 to 4 principal nodes, then you will have to mention the label, like you can write V1, V2, V3, V4 or you can mention VA, VB, VC, VD or if you want you can mention VP, VQ, VR, VS. You will have to just mention the label among all the principal nodes in terms of voltage. This is about the second step. So the first step is the selection or the identification of the principal nodes and the second step is just labeling all the principal nodes with respect to that reference node, that means with respect to ground connection. These are 2 steps, while in the third step you will have to write node equation, or I can say you will have to write particular equations related to that principal nodes. In this step you will have to use KCL, Kirchhoff current law, for the writing of nodal equation. I am just mentioning the step, I am again mentioning step third means just label the principal node and again come with the step third. So you have done with the identification of your principal node. You also mention the specific labeling related to each principal node. Now the third task is write equations. Suppose you have 3 principal nodes. In that case you will have to write 3 equations. If you have 2 principal nodes, then you will have to write 2 equations, each equation indicating for each node. Similarly, if you have 4 or more principal nodes, in that case you will have to write 4 or more equations. Now these equations are said to be node equations because this is a nodal analysis, or you can say these are nodal equations because you are using node, or I am again repeating, node means simply a junction where 2 or more branches are connecting. Fine. So in the third step you will have to write specific equations, and for the writing of this equation you will have to follow the concept of KCL, that is Kirchhoff currents law, which I already discussed in my last video. So you can follow, you can learn how to write KCL, how to what is the concept of KCL. You can follow the my last video related to network theory, and with the help of KCL and Ohm's law you may obtain all the relevant equations related to your nodal analysis. This is the third step, while in the last or in the fourth step, this is just a basic step based on maths concept, because now you have almost all the equations. Now you will have to solve these equations with the help of basic mathematics concept, basic maths formulas. Fine. So after this fourth step, now you have all the relevant voltages across any branch of the circuit, or all the relevant current across any branch of the circuit. So once you have done solving of all the equations from step 4, now you have all the variables in terms of voltage and current for any branch of the circuit. So as per the demand of the question, you can give the specific answer related to any specific example. This is the basic concept of the nodal analysis. So I am just concluding all the 4 steps. In the first step, you will have to identify all the nodes, all the principal nodes, and nodes means simply a point where number of branches are connecting. Once you have done with the identification, you will have to mention a one principal node as a reference node, that means a ground connection. In the second step, you will have to label all the relevant principal nodes. The labeling may be in terms of V1, V2, V3, like VA, VB, VC, depends on you. It is not a standard protocol. You will have to take it your own. You can mention any of as per your own choice. In the third step, after the labeling, you will have to write nodal equation. Number of nodal equations depends on number of principal nodes. If you have 4 principal nodes, you will have to write 4 equations. If you have more than 4 or less than 4, you will have to write all these nodal equation in terms of KCL and Ohm's law. Fine. And in the last step, you will have to solve all the equations, and just to solve all these equations, you will have to use the basic mathematic concept. You can use variable elimination method, or you can use substitution method, depends on your choice. You can learn this with the help of any of the example. So after these 4 steps, you have all the variables related to your electrical network in terms of voltage and current for any of the branch of given network circuit. Now, as per the demand of the question, you can give your answer in terms of any of the variable which is asked by the examiner. This is the basic concept related to node analysis. So, now I am taking an example of node analysis, since I have already discussed all the steps, relevant step that is going to be used in order to solve any question based on node analysis. So, the question is, the examiner may ask question in terms of like find current across any of the branch. Just like I am giving a question, or the question is find out the current flowing across this 20 ohm resistor. Question may in a different form, it may like what will be the voltage drop across 20 ohm or this 10 ohm or this 10 ohm or this 5 ohm. The question may be in any of the form, but examiner will ask two things, either voltage drop across any of the branch or current flowing across any of the branch. So, my question is what will be the current across this 20 ohm resistor? Fine. So, I am just taking all the 4 steps one by one. I am using all the steps to solve this question. And as I told you, the first step is just identify all the principal nodes, and the nodes are a point where 3 branches occurs. So, here just by analyze this question, you can say that here you have this one is treated as a principal node. Fine, because here 1, 2 and 3 branches are connecting at this point. Similarly, this point can also be considered as a principal node, because again here 3 branches are connecting. Similarly, this one, any point across this wire is considered as a principal node. Now, you can say that just by observing the circuit, you can say that here you have 3 principal node. Once you have done with the identification of the principal node, the first step also include the identification of a reference node, and as I told you, reference node means a point to mention the ground connection. So, out of these 3, this principal node I am taking as a reference node. So, now you can say after the analysis of the circuit, in first step you can write a small conclusion that here you have 3 principal node in which this node is taken as a reference node, that means as a ground. This is about the first step, done. No mathematical calculation, no network concept, just the identification. Now come with the second step, and in the second step you will have to label all the relevant nodes. Label means you will have to mention the voltage across that specific node. As I told you, you can write V1, V2, you can write VA, VB, it depends on your choice. So, I am taking V1 and V2. Since this is a ground terminal, that means no need to mention V3, because the voltage across ground terminal is always taken as a 0. So, no need to mention any labeling across reference node. So, except this reference node, I have 2 principal nodes, and in the second step I labeled both the principal node. This is about the second step. Now come with, I am just mentioning V1 and V2 as I label both the nodes. Now come with the step third. In third step, this is the important step, you will have to write node equations in terms of KCL and Ohm's law. So, since here you have 2 principal nodes, so you will have to write 2 equations. Now, I am writing for first node. First node means this one. Now the main concept starts. The first task is you will have to follow the concept of KCL, and as per the concept of KCL, the total current at any node is always treated as a 0. That means the entering current is always going to be equal the leaving current at any specific node. So this is your first node, because I am writing for the first node. The first task is you will have to mention the direction of the current, and again it depends on you. You can consider it as an entering current, you can consider it as a leaving current. That means you may mention it that the current is entering across this node, or if you want you can mention that the current is leaving from that node. It depends on you. The answer at the end of the fourth step, the answer will be the same. So the next task is writing the equation for both the nodes, and for that firstly you will have to mention the direction of the current. Here I am taking entering. Suppose the current is entering from this branch, the current is entering. Similarly I am taking that for this branch current is leaving. You can mention at its your own, depends on you. I am again repeating, this is my concept. Here I am using that particular line, that particular indication for the current flowing, but you can change it. I am again repeating, no need to learn this. Fine. Now for this third step I am again mentioning that the current is leaving from that node. So for the first node what I did, I am just saying that from this branch current is entering, while from these two branch current is leaving. Fine. Now start writing with the help of KCL and Ohm's law. So as I told you that KCL means total entering current is going to be total leaving current. At this node from here the current is coming. Now by following the Ohm's law you can say that I is always equals to V by R. That means the current is coming from this point. The voltage will be 20 minus V1, because for this branch, since the current starting from here and ending at this point, that means out of these 2 points the higher potential value is 20, while V1 is at lower potential. That's why I am writing 20 minus V1. If you are taking opposite direction like this, then you will have to write V1 minus 20. So as per the direction of the current, the voltage drop indication may differ. It may be 20 minus V1 or V1 minus 20, depends on the indication of the current. And since I am taking like this, that's why I am mentioning the current across this branch will be V by R. So what will be the V will be 20 minus V1 divided by R. Across this branch R is 5. So at this node the current is entering from this branch and the current is V by R. And as per this is the concept of Ohm's law, and according to KVL the leaving current is going to be equals to entering current. Now what about the entering current? The entering current is going to be equals to the leaving current. This is your entering current, because the current is entering is this node, as per my opinion. I am again repeating, this is not a standard concept. You can change it, you can mention it as a leaving current also. Meanwhile the concept will be the same, the process will be the same. Now come with this branch. Since this is a leaving current, now you will have to mention that particular current with the help of Ohm's law, that means V by R. So for this branch the current starting from here and ending at this point, that means the voltage will be V1, that means at that point, minus voltage at this point, and this is as a reference point where voltage is going to be 0. So V1 minus 0 divided by resistance, that is 10. Fine. Similarly for this third branch, this one, the current is leaving from this point and coming at this point, that means voltage will be V1 minus V2. higher potential minus lower potential divided by resistance, and the relevant resistance for this branch is 10. So this is the node equation for this first node. Now you have first node equation. Now you will have to write a node equation for the second node. So for the second node means this node, and before writing the equation in the first step is, the first thing you will have to mention is the direction of the current. Now see, again just focus here, over here, for this point you already mentioned that from here the current is coming. That means here the current is coming as per the direction in the previous node. For these two, from here you can say the current is already coming over here. Fine. So no need to rechange this. The question is itself indicating that 4 ampere current is coming toward this. For this you already mentioned in the last step. Now this branch is remaining. It depends on you. If you want, you can mention coming over here. If you want, you can mention leaving over here. Depends on you. I am just taking that the current is leaving from this node. So the direction of all the relevant current is already mentioned. Now start writing. And the concept of KCL is total entering current is equals to total leaving current. So at this point the current is coming from here. That means the current is entering. So you will have to mention the entering current is equals to leaving current. Fine. So what about the entering current? This one and this one. Plus 4. 4 is coming from here, the current is also coming. So you will have to mention the current with the help of Ohm's law, and as per the concept of Ohm law, current is equals to voltage upon resistance. So current is coming from here, so it will be V1 minus V2, higher potential minus lower potential, divided by resistance, and the relevant resistance is 10. Fine. So at this node the current is coming from this branch, and the current is V1 minus V2 upon 10. Similarly, the current is coming over here, which is 4. So plus 4 is equals to leaving current. Leaving means the current flowing from this branch. So again, following the concept of Ohm's law, that the current is going to be equals to voltage is at this point minus voltage at this point, which is 0, divided by resistance 20. So this is your equation 2. So in your third step, you have, from the third step, now you have equation for both the nodes. This is for the node 1 and this is for the node 2. Now in the fourth step, you will have to solve these two equations. You can just see that in this equation you have two variables V1 and V2. Similarly, in this equation you have two variables V1 and V2. So you have two equations and two variables. So in the last step you will have to identify the value of these two variables with the help of mathematics concept. So this is your last step, and the step fourth is identify V1 and V2. Fine. So the first thing I am doing over here is, I just want to solve these equations. So I am just writing it, both the equation, in the simple form. What I am doing actually, I am just taking LCM for this equation, or you can say that the LCM of this equation will be 10. So here you will get V1 minus V2 plus V1 is equals to here 20 minus V1. So you can write this equation like this. Fine. Or you can write it like this. This is your equation cell. Or if you want, you can solve it. 40 minus 2 V1 is equals to V1 plus V1 minus V2. Or you want, you can write like this. Just substitute V1 and V1 and V2 one side, while the constant is another side. So it will be V1 and 2 V1. So it will be 4 V1 minus V2 is equals to 40. This is your equation 1. for the node 1. Now come with this this equation. Just try to solve this equation, and here I am again taking the LCM, that will be 20. So V2 is equals to 80 plus 2 V1 minus V2. This is your second step. This is the equation from the second step. Now try to solve this. The equation will be 2 V1 minus 2 V2 plus 80 is equals to V2. Or you again just put V1 and V2 one side while constant at the other side. So it will be 2 V1 minus 3 V2 is equals to minus 80. This is your equation second. So now you have two equations. Now I am erasing all the things and writing the simple equations. 4 V1 minus V2 is equals to 40. This is our equation 1. Similarly 2 V1 minus 3 V2 is equals to minus 80. This is your equation 2. Now look both the equations. There are several methods to solve these two equations. This is just the basic concept from the mathematics. The most preferable method is elimination method. Just try to eliminate any one of the variable among these two, and then after the elimination of one variable, when you will have only one remaining variable in the equation, you can find the specific value of that variable. Like this, if you want to eliminate any one of the variable among V1 and V2, suppose you want to eliminate V1 over here. So my suggestion is just multiply this equation by 2, because once you are going to multiply this equation, it will be 4 V1, and here you have already 4 V1. So by the subtraction method you can eliminate your V1. So the equation first is multiplied by 1 because you do not want to change that equation, while equation second is multiplied by 2. So after the multiplication, what will be the result? 1. When this equation is multiplied by 1, no change. Equation will be 4 V1 minus V2 is equals to 40. While your second equation will become, when it is multiplied by 2, 2 into 2 4 V1 minus 3 into 2 6 V2 is equals to minus 8 to just 16. So now you have these two equations and you want to eliminate V1, that means you will have to subtract, and after the subtraction it will be eliminated. Now you have 6 V2 minus V2. So it will be 5 V2 is equals to 40 plus 160, 200. So your V2 is going to be 200 divided by 5, 20 volt. Now you can calculate the value of V1 just by putting the value of V2 in any of these two equations. I am taking equation 1, which is your 4 V1 minus V2 is equals to 40. Here at the place of V2 I am putting 40 because V2 is equals to 40. So it will be 4 V1 is equals to 80. So your V1 is equals to 40 upon 2, that means 20 volt. Fine. So now you have, after the fourth step, you have both the values V1 and V2. Just by you are getting these two values just by solving both the equation. Now come with the question asked by the examiner, and your question was, firstly I am writing V1 is equals to 20 and V2 is equals to 40. Now come with the question asked by the examiner, and the question was, find the current flowing across this 20 ohm resistor. So the current across 20 ohm resistor will be I is equals to V into R, because I is equals to V by R. So current across 20 ohm resistor will be voltage across 20 ohm divided by 20 ohm. Fine. So what will be the voltage across this? The voltage will be V2 at this point and 0 at this point. So it will be V2 minus 0 divided by 20, and the value of the V2 is 40 divided by 20, so 2 ampere. So the answer is 2 ampere. That means the current flowing from this 20 ohm resistor is 2 ampere. If examiner want to know what will be the voltage across that point, you can say V2 minus 0, that means 40 minus 0, that means 40 volt. If examiner want to know what will be the voltage or current across this 10 ohm, this is the additional part of the question. So if examiner want to know what will be the voltage across this 10, you can mention V1 minus V2 or V2 minus V1, depends on the direction of the current. Similarly, you can find the current also. So once you have done with the calculation of these two variables V1 and V2, it will be easy to identify any of the variable, any of the voltage drop across any branch or the current flowing from any of the branch. So this is the basic most simple example that is based on node analysis. There are more several methods that are used to solve such kind of questions, but the simplest method to solve such kind of electrical networks is node analysis. Fine. So this is the basic concept about node analysis.